So we're learning about property of logs because now we're talking about logs. However, it's good to review the property, of exponents because the property of logs and the property of exponents are similar to each other since the two are inverses of each other. So the property of exponents, we're going to go ahead and write that first. There are three. You learned more than three when you learned about exponents, but there's three that are important. The first one is if I say x squared times x to the 7th, how would you simplify that? X to the 9th. So when you are dealing with exponents, multiplication in a problem really meant that you were adding your exponents together. So that is one of the properties of exponents. Another property of exponents is if we had x to the 15th divided by x to the 12th. Anyone know what that would give you? Yeah, you subtract, you get x to the third. So division problems are really subtracting your exponents. And then if we had x to the third and we raised it to the second power, what would that give us? X to the 6th. And the reason it works like that is because this is actually x to the third times x to the third, right? Something multiplied by itself. And so it works that way because you have two sets of x to the third. That's why you're able to multiply these two exponents together, is because two sets of it would mean you're adding the exponents together. And 3 plus 3 is 6. Or 3 times 2 is 6. Alright, so the property of logs is like the reverse of that. So if I said log 6 plus log 3, addition for us is actually going to mean multiply the numbers. So this is going to give us log 18. So with exponents, multiplying the bases means you add the exponents. Here, adding the bases means you multiply the numbers. So add really means multiply. All right, if we have log of 6 minus log of 3, subtraction really means division. And 6 divided by 3 is 2, so that would be log of 2. So subtraction really means division.
Hold on, wait, I just asked a question.
Yeah.
Is the 6, is that just supposed to be a regular number, or is it supposed to be like...
Well, log of 6 would be some sort of weird decimal. But yeah, this is the number 6. 6 times 3 is 18. 6 divided by 3 is 2.
So it's not like a little base and
It's not a base, no. So if I didn't write a base on these logs, what base is actually there? 10. These are all common logs. They're all base 10. And I was doing that to be lazy. So these properties of logs, it works. You could say log base 2 of 6 plus log base 2 of 3 equals log base 2 of 18. I just didn't feel like writing the 2's every time. All right, and then the last one is 2 log 6. And 2 log 6 is really saying log 6 plus log 6. It's saying that you have 2 sets of log 6. So before, it's kind of similar to this. Remember this said it was 2 sets of x to the third. This is telling us 2 sets of log 6. And so this is actually log of 6 squared. And that's because you would multiply these. 6 times 6 is 6 squared, or else you could say 36. So anytime you've got a number in the front, it tells you how many sets you have. And that means, since it's repeated multiplication, in this case, repeated multiplication means that we are repeatedly multiplying that number. That makes that an exponent.
Jesus Christ.
So 6 plus 6 is 2. 6 to the second. All right. So those are our 3 rules. That's what we're using today. That's it. All right. So we're going to practice these. There's two different words here. We might call this like this is the problem and this is the simplification. Might be how we'd refer to it before. When you're dealing with logs, you would call this side the expanded side because it's got like multiple logs, like different pieces. And you would call this the condensed side because you narrowed it down to just one log. Does that make sense, the wording that we use there? So, and they have you go back and forth. They might say start with the expanded side and condense the answer. Or they may say to start with the condensed side and expand your answer, and you have to be able to comfortably go back and forth. Okay? But these 3 rules are the rules that we're going to use. So we are going to start off with condensing logs. So this is log base 2 of 5 plus log base 2 of x. And this is the expanded form. I can tell that it's expanded because the word log is used twice. So for us to condense this down, we only get to use the word log once. So we're going to say log base 2, and we only get to write it that one time. And this is a plus problem, so what are we actually going to do? Multiply. And what are the things we're multiplying together? 5x. So this is log base 2 of 5x. Yeah.
Can you only do that if you have the same base?
You can only do it if you have the same base.
What if you don't have the same base then?
Then you'd be like, nope, done, that's it. So if this was a base 2 and that was a base 7, you'd say like it's as condensed as it can be. There's nothing I can do with that. So they gotta be the same. All right, here's the next one. ln 3 minus 2 ln x. So can somebody remind me what ln actually is?
Log to the third.
Not log to the
It
third.
stands for n. It's
Log,
actually
yeah,
natural
it's a log with a base of
natural log.
e.
There you
It's a
go.
natural log. It's a log with a base of e. So these rules still apply even if it says ln.
Okay.
It's not anything different. It looks different. But it's not anything different. It's still considered to be a log. Because it's log base e, we just write it in a special way. All right, so we have ln's. They match, right? ln and ln. So our answer is going to have ln in it one time. And we've got a minus sign, so what are we doing? We're going to be dividing, so I know I'm going to be taking ln of a fraction. So 3 goes on top. And then on the bottom, what did you say goes on bottom? X to the... Yeah, so this 2 right here is telling us we've got 2 sets. And when we have 2 sets, that's going to make an exponent. So that 2 actually goes as an exponent to the x. So we've got 3 divided by x squared.
So what if there was 3 instead of 2 that gets to the third?
X to the third, yep. All right, I'm going to give you 3 this time. So log base 5 of 6 minus log base 5 of x plus log base 5 of y.
I'm sorry. You gotta do condense. You want to
So we're going to condense.
You sure?
All the logs are the same. So we get to write the word log one time.
What incarnate?
Wait, what if it was like
You get twisted it.
2 with the base 2 is like
If 2 of the bases were the same, then you could put those 2 together, and the third one would just have to be the oddball. So log base 5, and then what do we have? 6 divided by x. What's the plus tell us? Times y. Alright? Now, most people would not really write it like that, although this is not incorrect. That is a good answer. You can leave it like that. Most people would say log base 5 of 6y divided by x. That's what most people would do. So when you are condensing, because most people would think of this as a y divided by 1. Right? And then if you had y divided by 1, you could multiply the tops of the fractions to get 6y and multiply the bottoms of the fractions to get x. So a good way to think of this is when you condense it down, if it's got a minus in front of it, it goes on the bottom of the fraction. If it's got a plus in front of it, it goes on the top of the fraction. That's a good way to remember it.
No matter where it is.
Yep, no matter where it shows up in the equation. Minus means bottom, plus means top. All right, let's try one where it starts to look more complicated than it is. So ln 3 plus ln of 5x plus 2. Yeah. His class is often really loud. He apologizes pretty much every day. Sorry, my second period. Sorry, my third period. Sorry, my fourth period. And I'm like, it's cool. All right. So we write ln one time. And then what are we doing?
You gotta distribute.
So you can distribute, certainly. So why are you thinking you have to distribute?
It's multiplication.
Multiplication. So we're doing 3 times 5x plus 2. So this would be like, yep, I need to multiply those, but I haven't done it yet. And then Tucker was saying we could actually multiply that out. So what would we get if we actually did the multiplication? Both of those are good, correct answers. So the important thing is it was a plus, we knew that we were multiplying. Okay, we're going to do one last one like this before I let you practice. 2 log base 3 of x plus 1 minus log base 3 of x plus 1. Yep, so they're log base 3. What do we do with that 2?
Would it make a hole?
It doubles, right?
It means there's 2 sets. So I'm going to cross this out and I'm going to say 2 here.
So do you have to...
And this is a minus problem. The number in the front is always an exponent for whatever you're taking a log of. So I was taking a log of this group, and so the exponent goes outside the group. Yeah.
Plus 1.
Yes. So what did you put?
Well, at first it would be x plus 1, x plus 1, that's x plus 1.
Yeah, so x plus 1 squared over x plus 1, right? And then what did you notice about this? Yeah, there's, on the top, there's x plus 1 times x plus 1, there's 2 of them. So the one on the bottom can cancel with one of the ones on the top.
Oh.
This
Yeah.
is the part where we scratch out the 2.
We said x plus 1 squared over x plus 1, and we noticed that x plus 1 squared
Oh,
means
so
that
you
there's...
added the 2, what the 2 was in there? Alright.
I put the 2 because of this part right here. Yeah.
So I catch that 1.
So it cancels out one of them, and then there's still one left over on the top. Now, you can actually kind of see this if you look at the original problem. The original problem said you had 2 log base 3 of x plus 1, and you subtracted one of them.
Oh, I see it.
So if you subtracted one of them, how many do you have left over?
1.
Log base 3 of x plus 1, you've got one of them left over.
So basically, that second part was like the answer.
Yeah.
That's
You kind of could have got it either way just by like thinking about it. Yeah. See, so math ties together. It ties together.
wow.
Alrighty, so there are 4 things we have to remember. Alright guys, ready? When you condense, there are 4 things you have to remember. The first thing you have to remember is that you only get to write the word log one time. Just once. The second thing you have to remember is that plus really means multiply. The third thing you have to remember is that minus really means divide. And the fourth thing you have to remember is a number in the front becomes an exponent. Those are the only 4 things you have to remember to do condensing. Yes?
You only have to write log once if
Yep.
the bases are the same. Right?
Yes. And I will always give you problems where the bases are the same. If they aren't, it was a typo. To be honest, typically in this sort of problem, they don't often mix up bases. I could see them doing it in calculus to like make sure that you checked that they were the same. But in Math 3, we're not trying to trick you. We just want you to be able to condense it.
I can't hear you.
All right, expanding logs. I mean, you could do some examples on the front side if you want to. So the first one that we're going to expand is log base 5 of 3xz. I'm not trying to mess you up. A lot of math people cross their z's so they don't look like 2's. It's very common.
Okay.
So when you look at these, you want to think about how many times you're going to have to write log because it helps you break things up. So I've got 1, 2, 3 things. Can you guys see that? I've got a 3, an x, and a z. And so I'm going to be writing log base 5 3 times. And these are all being multiplied together, so what should be in between them? Plus. So I've got log base 5 of 3 plus log base 5 of x plus log base 5 of z.
Basically, how many things are in the parentheses are
All right. Now we're going to try ln. We're going to throw an exponent in there. We're going to do 3 over x squared. So here, I'm going to write log twice. Once for the 3, once for the x squared.
Should you put 2 in front of the ln?
And the 2 is going to go in front of the ln because that's squared. That's exactly right. So I'm going to start with ln 3. And then what am I going to do next? Yeah, I'm going to say minus. And if you want to write it as minus ln x squared and then remind yourself to take the squared and move it to the front, I've seen some students that need to think of it that way. So they can think of it as 3 divided by x squared and then just know to move the squared. Some students are able to do that in their brains all at once and say ln 3 minus 2 ln x, and whichever way your brain works is totally fine. So that's how our final answer should look.
Ms. Rice, you have a nice handwriting.
Thank you.
Yeah.
It has improved a lot since I started writing where other people needed to read it.
Yeah, I mean, that's
For a
I
long
like
time.
every time I watch your videos, I'm like, damn, that's nice.
All right, log base 2, and this time I'm going to give you guys a complicated one. Are you ready? So how many times are we going to write log base 2? 5.
Oh, write it.
What is that? And if it has a cross, it's
There's no D.
6 y.
How do you see
Right there.
So why are we going to write it 5 times?
1 for the 5, 1 for the x, 1 for the 6, 1 for the y.
Yep.
That's a lot of right.
1, 2, 3, 4, 5. Yes.
So how do we know it's log 6 and not log 2?
This is log base 2. Did I say log base?
The 6. How do we know it's not log 2 plus log 3?
So, yes. So, if you wanted, you could expand this into even more terms than 5. What he's saying is, how do we know that we're supposed to write a 6 and not break it apart as a 6 can be divided as a 2 times 3? Right? Like, why are we calling this 6 times y times z and not 2 times 3 times y times z? The answer is if you wanted to be on a test, this is actually a smart kid like trick to annoy your teacher. if you want it to be obnoxious on a test, you could expand this out way further than it is. You could make the 5 a 1 times 5 and the x to the 4th x times x times x times x and actually write that many logs and make me check your work to make sure you were right. You can do that if you want. So typically we would say, if the number is a 6, just leave it as a 6. That's not a ridiculous question. You're exactly right to think of it that way. As like, so you could break it apart, and if you are mad at me on test day and you want to do that, you're welcome to do that. If you have some angst that you need to do that. You're not going to get extra credit. I'm going to be annoyed and then give you full credit. Is what's going to happen.
Can you give us a sticker? Like,
I'm not going to give you a sticker. I'm going to give you an angry face.
Okay.
All right.
Good job for pissing me off.
All right. Yes. Good job at being smart, stupid head. You know. All right. So let's get started. We got log base 2 of what? 5. All right. Then what do we have? Well, it depends what we're doing next. So which we want to do plus. So we want to do the x squared next.
Yeah.
Or x to the 4th. So plus
When we had 4 log x.
log base 2 of x. Yep. And then these are on the bottom, so we're going to go minus, 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 because all of them are on the bottom. So we're going to go minus, 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 because they're all on the bottom. Does that make sense? Yes. Minus, minus, minus. Okay? So minus log base 2 of 6 minus log base 2 of y minus log base 2 of z. We're minusing all of them because they're all on the bottom. So minus, minus, minus.
What do you multiply those together?
Yes. Another way, if that's annoying you, another way you could have written this.
Because I put log 2 6 plus log 2 y.
You can write it that way, but you've got to have a parenthesis. So I'll show you. If you write log base 2 of 6 times log base 2 of y times log base 2 of z, then you have to have this minus to show that your whole parenthesis is on the bottom. Does that make sense? Yeah. So you've got 2 different ways of doing it. You can say minus, minus, minus because they're all 3 on the bottom and I'm showing that. Or you can say put all this stuff on the bottom and then you can say this group was all being multiplied together just on the bottom.